Hey guys, this is Jason. How's everything going? In this video, I'm going to take a look at 138, copy list with a random pointer. A linked list is a given such that each node contains an additional random pointer which could point to any node in a list or null. Return a deep copy of the list. The linked list is represented in the input as a list of n nodes. A list of n nodes. Each node is represented as a pair of val, a random index, where val integer represents the value, the random index pointing to the next one, or null if it does not point to any node. So for something like this, we need to copy them, and this one, it means this one go to 2, random points to 2 also, next one null n, and random points self. Cool, so this one is the same, next, random, random, null. Well, so actually copy something like copy data structure, I think consists of 2 parts. One is traversal, the next one is a process. Just like we are copying the tree or graph, we first traverse through, find a way to uniquely traverse through the graph, and then every to process each node, we create a clone and connect them up, right? Copy the nodes and then connect them up. So for a linked list, it's very simple. It's one way with one path, right? So I can just loop through it with one pass, like find the first node. Okay, it is not, and copy it, and then copy the next one, go to the next one, copy next one, and then after all the nodes is traversed, we now handle the random and the index thing, right? Because for like this node, if it is randomly points to the last one, I cannot find the last one unless I traverse the last one. So there's nothing I can set. So first one I handle next, traverse them all, clone the nodes and put them in an array, and then do it again and update the random. Index, right? Oh, index? It means the index of the node. Well, so if that's the case, there is it too simple? Next, random. Node, wait a minute. The val, the index, the index of the node. A list of nodes. Head. A list is not array. It means a linked list. I'm sorry. The index. Yeah. The index. The random index. The next. This should be a node, right? It's not index. I think so. Cool. So this one. This is not difficult. I think so. We're doing this 2 pass. First, traverse all the nodes, clone them, put them into array, and so after we put all of them into array, we have index, right? 2, traverse all the nodes, set the random based on the index. Cool, let's do it. So we need a array, so nodes list like this, empty. Cool. The index will start from 0. Cool. So let p start. Should be start from head. So while start is not null, start equals next, and here we get the node, and we need to copy it. So we node list, create a clone equals new node. Val is start dot val and start dot. Wait a minute. Null random. Random is null. Okay. Now this clone created, and I will push it. Node list will push the clone, and then we move to the next one. So, and when we push it, we need to set if node list is not empty. We need to connect to the previous one, right? So node list, and then this is last node. Next should be the clone. This means because first one is empty, we push it. The next one, when we push it, we found 7, so we update the next. Yeah. So this will go on and on to null, right? Null because it's null, and it will stop. Okay. Now we will do it again. A star set to head, and we will do it again. Oh no, we will start on the node list here, right? Yeah, we can directly get the index. So okay, we move the start back to, okay, this is the second pass. Const result equals node list 0, right? Okay. Now with the second pass, loop through, not loop, yeah, walk on the linked list and array at the same time. Right, so start is set to head, and let, not set, okay, let p origin equals head, let p clone equals node list. No, I need to update. So I need to get the corresponding nodes. If I oh, I see. Okay. Let index p index clone equals 0. So while p origin is not null, p origin equals p origin next. But also we will get the clone, right? Clone equals what? We will get the node list index clone. After we get it, we will update the index 1. So now we need to update the random thing. So clone is the random equals, right? Random equals to I made a mistake. It gets random. It's not the shit. The random index is just the internal representation of the linked list. The random is actually the random, right? Yeah. So actually, I cannot get the direct index. I need to maintain a relationship between the nodes and the clones. I'm so stupid. Okay, so the node list is not necessary. We will get a new map. This is as a clone map. Okay, when we traverse through it, we create a clone, and we need to keep track of the previous one. So let's start with the falsy head. Const start false head equals new node val, doesn't matter. Next is head. Random is null. Okay. So now start is from falsy head. We'll get the previous one is empty, right? And then handle the next one. So the wait a minute. The while loop will end at the next one, which ends at null, right? Because there's nothing we can do. So while next is not null, we will clone the next one, which means start next. Clone it, and don't forget to update the clone map. So clone map set start next. Clone map set start on next equals to clone. Okay, now we need to still connect them, alright? Don't forget to create a false head clone. Do the same. The head will be null, then random will also be null. Okay. When we loop through it, and let's start equals the false head, and create a point on the okay, I'll use a point p start. Okay, let p start clone equals false head clone. Well, this. I look through the original linked list. We create a clone of the next one, and update the clone map, and we need to connect the clone with the previous one, right? So p start clone next equals not start actually. Okay, I'll set like this. I remove the start. This looks cleaner. P. This is p clone, and p start p equals p's next, and of course p clone equals p clone dot next. Right? Cool. So I think we need to remove the original implementation. Now let's see. We first use a p to traverse through the original linked list. When every time we met a new one, we clone on the next node, which is copying the value, but sets the next and the random to null. And then we update the clone map, and then connect the clone node in a new linked list, and then move the pointer to the next one, And so when these p ends, which ends at p next equals null, so p actually falls here. When this is done, when this is the last one, we will do nothing because there's nothing to clone with. So this is good. Only problem is that for the random, at the first pass, we don't know where the random should be, right? It might be already there, and it might be not, right? Or it's already, we could just create a new node. Yeah. Okay, let's first continue with our original idea is to traverse them all over again and update random. Okay, so p was set to false head again, p clone, we set false head clone. Well, I totally misunderstand what the problem is. I thought that we would have a direct a number of random index. It turns out I made a mistake. So we will use this while loop again. Well, for now, it's very simple. We just set the get the clone, which is clone map get p next, and we will update the clones random, right? Clone random equals what? Clone map get p next random. Right? So now finally we could return the false test clone dot next. Attention for the null. Okay, if the head is a null, we create equals null, so it will stop, and this will still stop. Yeah, I think it should work. We're accepted, but actually I think we could do it in one pass. Let's try to improve that. This is because of total misunderstanding of the problem. I'm so sorry. The time, well, actually, you see that we traverse to the node 2 times, so it's linear time. And the space, we use a map, right? So it's linear. So the second one with one pass, try to use one pass. It means when we handle a new node, actually we could handle the random or the next at the same time. Right? So for that, I think we will create a hyperfunction here. This is clone map, and I created a function called getClone, which is get a node. What this getClone do is if the clone map has it, clone map has node, I'll return it, right? Yep. If it's not there, we create a clone of it. So const clone equals new node val. The next one is null, the random is null, and then we set it, and then we return. So now it's like even the clone is not there, we can use this get clone method. So actually, I think we can omit this pass. So now when we are traverse to the next one, we don't need to initialize it. We could just get the clone, right? So const clone would be what? Would get clone p next. For like the 7, it's not there, so will be a new one be created, and we set p's next to clone map. Oh, it's already set, so we don't need to get the clone, and clone p clones next set to it, and what? And the clone the random equals get clone p random. Okay, p random might be null, so if it is null, we return null. And then we set the pclone to next, connect them, and then go to next one. So this should also work, I think. Let's try to review our code before we submit the code again. Submit the code. First, we get a false start. We get the 7. We get the clone of 7. It's not there. We create a new one, and we return it. So we got a 7. Okay, not 7 random. We get the clone for 7 random, which is null. Of course, we get null. It's null. We connect the 7 in the clone map, the 7 here, to the head. Both move to the next one, which is 13. 13 is same. We get the clone, put the clone, and get the random of 13, which is 7. But 7 is already a clone there, so we just return it. So we set the random to 7, and then connect this 13 to 7. So it should work also. Wrong answer. Why? Okay, let's see. Got 0. What is 0? The val? Huh? Get a clone random. Wait a minute. Wow, it's totally messed up. The input is like this. The first one we got it right, and this, the next one we didn't. What? We get the P next, which is 13. If it has no, we don't have it, so we clone it, which is node val, which is 13. The node is val. Okay, next one, null. Clone map set node clone. I return clone, and we get it, which is 13. The value is okay, but the random is not right. We set the random to P is random. I know what happened. The P next random. Cool. Now I think we are accepted. So yes, so this is actually has the same time complexity with the previous one, but it is better because we do it with one pass. The space also use a map, so it's linear time. This one is actually pretty easy to understand, right? The common approach of handling the linked list is as the false start. So we can just keep one step, keep the previous, like previous node, keep a reference to the previous node, so we can like do the deleting, do the insertion, something. Get a clone. Yeah, this kind of looks pretty straightforward, right? Okay, hope it helps. See you next time. Bye bye.